What the fuck? Really? Bookmark this tab. And put back the current tab. Nope. That sucks. That ain't good. Oh, I can paste now. Damn it. I think I've showed this a few times this semester. Unbelievable. Here we are. Hey, Mr. Fish. Well, I got my work cut out after. I got my work cut out after this stream today. Alright. Hey. Audio check. How does the audio sound? Audio. Check, check, 1, 2. Audio. How do we sound? Audio's good. Now, what about the video? Up. There you go. That's the video. How do we look? Well, the light is on now. The light is on. Makes a big difference. Lighting makes a big difference. Audio good. Hey, Bo CTG. Hello. All right. Well, I'll post this afterward. I did post a link in the Twitch stream. This is the 2024 CWE Top 25 Most Dangerous Software Weaknesses. Yeah, I'm just going through this right now, and it's like, really? Cross-site scripting is number 1. Unbelievable. Well, hello everyone. I'm Ming Chow, Associate Teaching Professor at Tufts. Yeah, so this is 11 episodes in, and I have some news to tell you. Kind of sobering news, but today's the second to last stream of the semester. Yeah, this is going to be the second to last stream of the season. Yes, I think we're at episode 11 right now. We're not going to have anything next week because of Thanksgiving. Want to wish everyone here a happy Thanksgiving and safe travel for next week in advance. So yes, happy Thanksgiving, early Thanksgiving. Safe travels to everyone who's going to be traveling. Yeah, this is the second to last stream, and it's always for me a trip down memory lane. Because today, the emphasis is going to be on forensics. Yeah, forensics. Forensics, yeah, as you might have heard that term before. People may have been very familiar with like CSI TV shows. But forensics brings back a lot of memories because I used to do some work with law enforcement. And I have a lot of shout outs, lots of shout outs today to groups and people, individual, that helped me get to this point. And only great memories. Only good stuff to say. I was actually just I wanted to go message on LinkedIn, and then, of course, someone sent the 2024 CWE Top 25 weakness list, and I was like, oh shit, I got to deal with. Well, okay. Anyway, so yeah, I used to do some work with law enforcement. Used to give trainings. This was over 10 years ago. And, you know, you always never forget those who actually helped you to get to where you are today. And of course, there's always been great stories to tell. But yeah, one of the, if you all recall on the first lab, the Linux lab, command line, there's a question I asked. Here's a little motivation. Remember this question which I asked, like, what command can you use to securely delete a file? Question number 13. What command can you use to securely delete a file? The wrong answer I was looking for was RM. So if anyone ever deletes a file using the trash can, empty trash, RM, it does not securely delete a file. You can always recover it. And the motivation is, well, that question. And today I'm actually going to show you how do you actually recover deleted files? Or in other words, why is RM not a good option if you want to securely delete a file? Yeah, so the answer that I was looking for, the right answer is something like shred. Shred securely deletes a file. But for those who actually put rm as the command to securely delete a file, it's the wrong answer. Yet, it actually is it's what I call wrong answers only, good wrong answer, because today we're going to actually recover deleted files. Okay, so today I'm just going to run over a few slides. What we're going to do today is to learn how to acquire data from disk using DD. We're going to analyze an image of a disk from DD using forensics tools such as SleuthKit and Autopsy. And foremost, they're free and open source tool. And we're going to recover deleted files off of a disk. This is what we're going to do today. So today is going to be very hands-on. DD analyze an image of a disk from, copied from DD. We're going to use forensics tool. Yeah, we're going to recover deleted files off of a disk. Um, in fact, I actually have it publicly available, so if you want to play along, let's go. But before we actually do anything hands-on, let's get through not only some terminology, but also a stripped down memory lane. So the scenario is this. Imagine, last week we talked about malware, but what happened if you actually have been attacked, compromised, or if you were involved in a criminal incident, such as that you downloaded like illegal content from the dark web? Um, if you're the investigator, like what's the evidence, what happened, when did it happen, who was involved. So you can see here there's a lot of the who, what, when, where, why. So imagine this is a scenario. Um, this also, if you are involved in not just ransomware, but also things like harassment cases or intellectual property theft. You can even add those as scenarios. So if you were if you're ever doing an investigation, like who, what, when, where, why. So what is forensics? So forensics is the preservation of computer media, identification, extraction, interpretation, and most importantly, documentation. It's a process. So it's a full process to, preserve the evidence, identify the evidence, get all the information possible, and then document. So one thing to let you all know is when documentation is the by far and away the most important thing, and also interpretation, because your work can be used in the court of law. Yeah, you get to leave no stones unturned. You have to be 100%, 101% sure of what you are doing and finding. Oh, yes. So, again, your work can be done, it can be used, will probably used in the court of law. Now, the process really is, assess the situation, acquire data, analyze data, report. So, this is a definition of forensics. But this is really the step-by-step process. Assess the situation, acquire data, analyze data, report. So we're going to do a lot of, today we're going to focus a lot on acquiring and analyzing data. Not so much on the reporting part. I mean, that's a really intensive writing exercise. Now, before you go and assess a situation, you have to obtain a search warrant. And here's an example. Here's actually a screenshot of an application for a search warrant for in the Commonwealth of Massachusetts. There's the application. Um, you have that there is probable cause to believe that the property described below has been stolen, has concealed, unlawfully possessed, or concealed for an unlawful purpose. This is the application to go and use for search warrant, to, apply for a search warrant in the Commonwealth of Massachusetts. Um, this is, do you have to sign under the penalties of perjury? Cool. Okay, and here is what a search warrant actually looks like. The search warrant, um, here it is. You are therefore commanded with reasonable time and in no later event than more than 7 days from the issuance of the search warrant to conduct search for the following property. Also, on the back of the search warrant is an inventory sheet of everything that you collect. If you're an investigator. Yep. Yep. And so this is a list of like all the boxes, and I've executed as followed. Yada yada yada. This inventory was made in presence of. Got to have a witness. Okay. So things that you take during a search. Um, if it's computer media, computers, that also includes desktop, laptop, phone, mobile devices, and also very important, the router. So you see that as well. USB drives, thumb drive, external hard drive. You take it all. Okay. Yep. Take them all. Monitors, I believe so. Is that yeah? I mean, monitors these days have a computing have a computer chip inside them too. So yeah, you take those as well. So keyboards. So it's gonna be boxes, lots of boxes. Now, what are you trying to collect, especially from computational devices? What do we care about in a forensics investigation? You care about volatile data and non-volatile data. Non-volatile data is what we all know of as like things like hard disks, USB drives, thumbsticks, um, floppy disk, if there's any these days, CD-ROM. That's non-volatile data. Volatile data is also can be really critical as well. Volatile data is data that changes all the time. This includes RAM and processes. One of the worst things that you can do in a forensics investigation is if you actually arrive at the scene and you see computers running, one of the worst things that you can do is just to pull the plug and just turn the computer off. That's one of the worst things that you can do because there's a lot of evidence that can be stored in RAM. So, for example, anything that do with payment card systems, like there could be payment card system, payment data, and other like and passwords. List goes on. That are stored in memory. So you got to have a way to get the processes and also data off of RAM during an investigation. Now, the two other terms that are actually really important for forensics are physical acquisition and logical acquisition. Um, there's a difference. A physical acquisition is a bit by bit copy of an entire physical store. Oh, shoot, you know what? In this case, I always need to get show and tell. Hold on, un momento, por favor. Alright. Okay. So I have here a there it is. That is this is a solid state drive, a T7 Samsung portable SD. Okay, this is what I use for personal for data. Now, a physical acquisition is a bit by bit copy of the entire physical store or the drive. This is 2 terabytes. I mean, a bit by bit copy of the entire 2 terabyte. The good news is you get a bit by bit copy of the entire physical store. Duh. You get a copy of the entire drive. The problem is it takes an asinine long time to do a bit by bit copy of an entire drive. I mean, if it's a 2 terabyte, 4 terabyte drive, it could take hours and days. Back in the days, to do a bit by bit copy of an 80 gigabyte hard drive, I mean that could take 6 to 8 hours. Okay, so it takes a long time. God forbid if you actually do a bit by bit copy of an entire physical store, and then the copying dies because there was, you know, because the drive actually had have a corrupted part of the disk, then you're screwed. So that's the problem. The other problem is you try to do an investigation of an entire physical drive. That's a lot of stuff to look at. Okay, so you're going to really find needle in a haystack. So the other option is to do what is called a logical acquisition. A logical acquisition is a bit by bit copy of only certain directories and files on a file system uh, or a partition. So where is this going to be used? A good example is Android. Android has a pretty big has a has a pretty big file system, and it's also well known too. Instead of taking an entire physical acquisition of the phone, maybe you don't need to do that. Maybe you only need to actually make certain copies of certain areas of disk, certain folders only, because that's where all where the data is actually stored. The good news is it's less time intensive. You know what you're looking for. I mean, it's like you're zooming down into certain areas of disk. The bad news is, what if you're wrong? You don't get a copy of everything. So there's pros and cons of both physical and logical acquisition. A write blocker. Now, here's the thing: when you're doing a bit by bit copy of a drive, what you hope that doesn't, the biggest thing that you hope doesn't happen is um, someone is actually writing stuff to disk. A really good example of that is what happened if you are trying to do a bit by bit copy of a compromised computing system that's using a botnet. And then all of a sudden, the bot master somewhere in another country say, "Oh shit, there may be an investigation going on. We got to turn this shit off." And then they kill the disk. That bad. I mean, then you have like evidence that can be gone. So a write blocker is important because there's no chance, absolutely no chance that anything can be written to disk. Write block is only going to do read. Once you plug it in, once you plug a drive in to a write blocker, it's only going to read. There's no chance of writing. Okay, only write commands. No, no, absolutely not going to happen. A write blocker is also a physical device, and they actually are not cheap either. They're like a couple $100. So I'll give you a few pictures of what write blockers look like. Here it is. Tableau is a write blocker. All right. So the hard drive gets put in to the write blocker, and then the copying goes out somewhere. Yep, the copying goes somewhere to like another drive, to another computer, you name it. And these are not cheap, at least a couple $100. Okay. Chain of custody is the chronological documentation of everything from cradle to grave, warrant, seizure, custody, control, transfer, analysis, and disposal. So these are some of the real basic forensic terminologies that are out there, that are there. This is like the basic stuff. Now the good news is this is the final topic of the class. It's not required, like when I'm not going to give an exam on this. But now, like this is like a subfield on its own. But it's also actually pretty cool to see, hey, there's another part of security that very few people think about. And here we are. To ponder what could possibly go wrong if you don't use write blocker to acquire evidence and data. Well, I just gave you an example of a botnet. So a botnet is like, hey, the bot master is like, oh shit, I'm sensing there's an investigation. Turn it up. You don't want that. No, 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 no. Yeah, you don't want any chance of evidence being eliminated or wiped out during copying of the data. What are the pros and cons of physical versus logical acquisition? When would you want to use one over the other? I've mentioned this already. Like Android, the file system, like the structure is very well known. You may be, that may, and if you don't want to copy like that much data, use logical. Otherwise, if you want to do a physical acquisition, hey, it's nice if you have all the time in the world. Okay, so forensics tools. What do they use in forensics? Believe it or not, forensics tools at the very rudimentary level are tools that you already know and use throughout this whole semester. Things like the most important ones are strings, and your hash checksum, your hash functions, MD5, SHA-1, SHA-256, SHA-512. Why is that? Remember, in forensics, arguably the most important part of forensics is the I in the CIA triad. What is it? Confidentiality, integrity, and availability. The integrity, you know, the hash values, checksums, preserve the integrity of the evidence. Because if usually there are multiple investigators working on a case, and if there is, if two people are working on a case and they're working on the same evidence, but one person actually that they download the same evidence, but the hash values are different, then something got tampered with. You don't want tampering of evidence at all. DD is a tool that is built into almost all systems. It's a grand old tool. We will use that next. DD is for if you need to copy or copy drives, write drives. Forensics Toolkit. EnCase is a commercial enterprise grade forensics toolkit. It's the one that law enforcement and government agencies swear by. It's also really expensive. Yeah, the EnCase. Oh, EnCase. Yeah, still around. Still around. Oh wow, they want cloud. Holy shit. No, it's not called an open text forensics. Huh. Yep, you can even do case backlog. People swear by this. Steg detect is to detect steganography. Capture the flag game, anyone? We're going to use SleuthKit and Autopsy. It's a free and open source alternative to EnCase. Manages your case, forensics case. Foremost is one of my favorite tools for forensics. If you just want to rip out all the pictures, uh, PDFs, text files off of a drive. Oh, I didn't say. Deleted, even deleted files as well. Really good stuff. So what we're going to do today is we're going to use DD, we're going to use SleuthKit and Autopsy, and we're going to use Foremost. Okay. Now, here is the evidence we are going to use for today's demonstration. Alright, I have this disk image here. Okay, this is a disk image. I am going to download it. 47.7 megabyte. Save that to my desktop. I'm going to save that to my desktop. 50 megs. Okay. Now, if you're on a Mac, you can actually double click on a DMG file. Open it up and take a look at the content. That's what I'm going to do. Oh, before I do that, do need my terminal today. What's the checks? Let's get the checksum of evidence.dmg, evidence with a capital E. DMD5 is 2cc. Okay, we'll leave this open. All right. That should be your SHA-256 and MD5 checksums of evidence.dmg. If you get a different value than that, means that the evidence may be tampered with. Now, I'm going to double click on evidence.dmg, and as you will see, and that drive pops up. So now what I am going to do is I'm going to double click and open up the drive. Alright, hold up for a second. I want you all to take a look right now at the screen. So there's no magic tricks here. No magic tricks. How many files do you see? No magic tricks. Says it right there. How many items do you see in the drive? Spot Ranger says 2. Bo says 2. Okay? 2 files. Perfect. You only see 2 files. One of them is this. The other one is a text file. Okay, you see 2 files. Will it look any different if I actually do, if I actually go to CD volumes, CD evidence, and I do an ls? How many files do you see? 2. ls minus l, you see 2 files. But what happens if I run ls minus la? How many files do you see? Not including the dot and dot dot, you see 1, 2, 3, 4, 5, 6, well, 1, 2, 3, 4, 5, 6, 7 files. 1, 2, 3, 4, 5 hidden files. So you see a total of 2 files that are visible, 5 hidden files. So far, so good? So far, so good. No magic tricks. Take a visual snapshot of the contents in the evidence folder, right, in the evidence drive. So you should, 2 files only. Okay? Now what I'm going to do is I'm going to delete both. Oh, shut up. Oh, I can't delete it. That's fine. What we're going to do in a few moments is we're going to see if there's any remove file. See if we can recover deleted files. That's what we're going to do next. Okay? I'm going to leave the terminal open. Now you may be wondering, how did I create this evidence disk image? And the answer is yes. You may be wondering how I did it. How did I do it? How do you do a bit-by-bit copy of a drive? If you want to do a full copy, let's say of this drive right here, this Samsung portable SSD T7 should be like 2 terabytes here. What do you have to do? Well, the first thing that you do is you plug in the drive. I plug the drive in, and you can see my personal disk is now in. The next thing that you do is this. Well, first of all, you do ls/volumes. And now you can see in the volumes folder, in the volumes folder of my Mac OS, there's 1, 2, 3 drives, 3 disk drives. the evidence drive that is mounted by double clicking on evidence.dmg, my hard drive, and the SSD and the solid state drive external that I just plugged in. Before you do anything, one of the tools that you can use, if you're on Mac OS, take a look at all the disks that are located, that are mounted on your system. The way you do that is a tool called DiskUtil. And this is only for Mac OS only. DiskUtil is to modify, verify, and repair local disk. This is actually, DiskUtil is a command line version of the disk utility tool. That's the disk utility tool. DiskUtil is the command line version of this graphical disk utility tool. Why did I mention that? Why did I mention DiskUtil? The reason why you need to use DiskUtil is you need to get the disk identifier of the disk that you are trying to copy. So if I run sudo DiskUtil list, here it is, and these are all the disks on my system. There is an internal physical, my solid state hard drive. Oh, no. That's disk 0. Okay. That's a full disk. Disk 3 is something. Disk 4 /dev/disk 4 is a disk image of some. Okay, that's the evidence. And /dev/disk 5 is the external physical drive, a 2 terabyte SSD. What you need to take from DiskUtil, let's say you're trying to do a bit-by-bit copy of a drive, you need to get the identifier. In this case, it's /dev/disk 5. If you are on Linux, you need to go and take a look at the /dev folder. Okay? So if I'm trying to copy, if I want to make a bit-by-bit copy of the entire personal hard drive, the personal solid state drive, first thing I need is get the name of the drive, which is in the form of /dev. So in this case, it's going to be /dev/disk 5. Here, I'm going to make a copy of that. Okay. You can also use the other identifiers such as disk 5 or disk 5S1 if you just only want a certain part of the disk drive. Sometimes drives can have like multiple partitions. Yes, you have to use the identifier. The identifier is going to be disk 5. That's the again, personal drive here. The next step is let's do a bit-by-bit copy of the entire solid state drive, all 2 terabytes. What you can use now to make a bit-by-bit copy of a drive is to use the DD tool. Now, fun trivia question. Does anyone here know what DD stands for? Take a guess. Take a guess what DD stands for. This is a good trivia question. What does DD stand for? The answer will shock you. DD. Before I run DD, what do you think DD stands for? Any guesses? Anyone? No guesses, huh? Ooh, disk drive. That's a good guess. Good guess. Not disk drive. Good wrong answer. It's a good wrong answer. Are you ready? DD stands for not disk destroyer. Another good wrong answer. DD stands for, drum roll everyone, convert and copy. Wait, what? DD stands for convert and copy. Yeah, I kid you not. DD stands for convert and copy. Man, DD. DD stands for convert and copy a file. That's what it is. Wait, how is that possible? Okay, so here's a little brief history of computing for you. When they were building the folks who built Linux, Unix, Unix. I think it was Ritchie, Dennis Ritchie, and a whole slew of people. Now, back in the days, people didn't, the gentlemen didn't like to type. So, how people typed back in the ye good old days was two fingers. Like MV, RM, CP, MV, RM, LS. You see a pattern here? There's a reason why so many commands in Unix and Linux are 2 characters, 2 to 3 characters max. Now, the problem is, we have a tool called convert and copy here. So you may actually would think, okay, convert and copy is CC. The problem is, VI, of course, is another 2-letter command. The problem with convert and copy CC is that was taken. You ever heard something called a C compiler? CC? It was already taken. So people say, okay, CC's taken, and we just bump up a letter to make it DD. So that's why convert and copy is now better known as DD, because CC is taken. So how you use DD is very rudimentary. So I'm on my desktop right now. So you do sudo DD. It takes in at least 2 arguments. DD takes in 2 arguments, in file and out file. Okay, so the in file in this case is going to be the disk identifier, which is /dev/disk5, and the output file is going to be, in this case, I'm just going to call it outfile.dd. All you need to do is hit the enter key, and wait till the next day. And that's it. That's how you do a convert and copy of, do a bit by bit. You do a bit by bit copy of a drive using DD, straight DD. Now, the problem is this is going to take forever. It's going to take a long time. The other problem with DD is there's 2 problems. Number 1, there's no verbose mode. You're not going to see much output. Like, the only output that you're going to see is when the drive finishes, or if DD hits a corrupted sector of disk and then the whole thing fails, or you do a Control-C. Okay? When you're finished copying a drive using DD, you're going to see the number of records in, the number of records out, the number of bytes transferred, and how long it took. K-dang pi, 40 seconds it took. So in 40 seconds on the Mac, I copied 4.56 gigabyte. Not terrible. Okay? Now you may be wondering, is it possible to speed up the process? And the answer is yes. So let's read this carefully. The description: DD Utilities copies a standard input to the standard output. Input data is read and written in 512 byte blocks. I repeat, input and data is read and written in 512 byte blocks. Can you speed it up? Yes. You can use the BS attribute, set it to some number of bytes. Here it is. BS equals n number of bytes. Set both input and output block size to be n bytes, superseding. Okay. Now, there's a caveat though. You can set BS to be like 5 megabytes. Okay. The good news is it will probably speed up the process. The bad news is, will there be some risk of missing stuff? The answer is yes. Okay. You can copy info. Read from the input file is IF. OF is the out file. Okay, so if you want to speed this process up, you do BS equals 5 megabytes. Hit the enter key, and it's now going to copy in 5 megabyte blocks. So this should speed up things a little bit, okay? But be careful though. The higher value that you use, you may run into problems like missing content and stuff. Okay, if I hit the Control C right now, 25 second, should be like 2 gigs. Yep, 2.6 gigs. Okay, not bad, not bad. Empty the trash. I don't need, oh, I can't empty the trash. I don't need this anymore. I want to take this out of my way. Thank you very much. Okay, so that's how you do a bit-by-bit copy of a drive using DD. Very easy to use. 2 arguments, input file, output file if you want, the BS as well too. You may be wondering, like, yeah, do people use DD all the time? And the answer is, believe it or not, the answer is yes. For example, if you need to copy stuff to or you need to make copies of SD cards, if anyone ever created created a drive for a Raspberry Pi, so if you ever need to create a disk image of a Raspberry Pi SD card, what you do, now here it is. DD doesn't have a both option. So what you do is for a Raspberry Pi, which is like the $35 computer, it's not $35 anymore. Go to raspberrypi.com, go to software. You select all download options. Let's say the 64-bit one. Say you download the Raspberry Pi OS with desktop. You download it. Okay. You're gonna download it's a compressed image file, IMG. So you have to unxz this file, like decompress it so you get rid of the .xz. But then what you do is dd sudo dd in file if equals 2024-111-19 yada 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 arm64.img. This is your in file. Your out file is going to be the location of your SD card. Your SD card. Yeah, that's how you make a bit by bit. That's what you use DD for, to make a copy of this image file to SD card. Yeah, so DD is used more often or not. Okay, let's use SleuthKit and Autopsy. All right, and this is where I'm going to use Kali Linux. And I'm going to blow this up. I am on my home lab server right now. Here we go. I'm going to fire up the terminal here. I'm going to go to my workspace. Go to forensics. Okay. So I have a copy of the evidence.dmg file. .64AF should match what I got, right? 64AF, all the other 3E3 EDA. Is that what I got here? Yep. Same evidence.dmg file. Now, what I'm not going to do, I should remove the output file for now. Okay. So what I am also going to do is I'm going to do a pwd. Copy the selection. I'm /home/defcon/workspace/forensics. I will need this for a very good reason. The next thing I do is, before I do that, I should let you know, I'm going to fire up a web browser on Kali right now. Kali uses Firefox. Now I'm going to go to SalutKit Autopsy. Go to saleuthkit.org. www.sleuthkit.org/autopsy. So if you go home to SaleuthKit, open source digital forensics. Autopsy is an easy to use GUI based graphical user interface based program that allows you to efficiently analyze hard drives and smartphones. SalutKit is a collection of command line tools and C libraries that allow you to analyze disk images and recover files from them. So they work in tandem. Okay, they work in tandem. SalutKit is like the engine. Autopsy is the interface. It's web based. So I'm going to fire up the terminal here now. And I'm going to type autopsy. Or did I do SalutKit? SalutKit not found. Aw. I can go. I'm on Kali Linux, and this is, SalutKit is installed with Kali. Got a forensics. And it's autopsy. All right. Sudo autopsy. Here it is. Autopsy Forensics Browser. One other note is, a lot of the forensics tools are built on the tools that we all know and love, like strings, like everything else, like strings, MD5, SHA-1. Here it is. Open a web browser on a remote host and paste this URL in it. Okay, localhost :9999/autopsy. Okay. Yeah. Here it is. Welcome. Autopsy Forensics Browser 2.2.4. We can open a case. We can create a brand new case. We can do help. Yeah, but I don't think this. I think this version of Autopsy has been installed with Kali for like a decade. I'm gonna create a brand new case, and this case is gonna call 2024-11. What's today's date? 21. Okay. Drive. Screen. Investigators. I'm going to have 3 investigators on this case. I have 3 investigators on this case. Optional. I'm going to create a brand new case. Here it is. Brand new case has been created in the file system. That's our live autopsy Twitch 2024-11/21. Okay. Select your name. I gotta select an investigator. I'm gonna select Bot Ranger. Add a host. So Bot Ranger is the partner in crime for today. Go get him, Gumshoe. Add a host. Host name. Name of the computer being, I don't know. Drive 1. Okay, description. Some evidence. Time zone, I don't know. You may be wondering, what is this thing called Path of Alert Hash Database? An optional hash database of known bad files. Also, you can put an ignore hash database. And you may be wondering, what's a hash database? So I'll give you a good example. Child pornography. So there is a database of known child pornography hash values. And so, of course, one of the most, horrible things that you can do for a job is to look at, child abuse images and stuff. The way you can, mitigate not looking at that stuff is to use a database of known images. And it's just a bunch of hash values. And so what happens is law enforcement has these. It's just a lookup table of hash values of child porn pictures. Load that in, and like an EnCase or a SalutKit, If it doesn't investigate, if it just scans the entire drive, it takes a checksum of every single file on the drive, and hey, if there's a file that has a check that has that hash value that matches something in the database, now you know that the picture exists on the drive, and you don't have to look at the picture. The same thing with the same idea goes for the ignore as well. So yeah, hash databases are really valuable. So it makes your life a lot easier, and so you don't have to be traumatized by looking at some of that stuff. Okay, we don't have one here. We don't have a hash database. We don't have to ignore one. Okay, so now we're going to add the host. We're going to add, now we must import an image file for this host. We're going to add an image file. I'm going to paste in slash home slash defcon slash workspace slash forensic slash evidence .dmg. Yep, here we go. So what is this thing? Is this a disk or partition? No, this is a full disk that was done in DD. Now you want to import it. You can do a symlink or an alias. You want to do a bit by you want to do a full copy of the image file, or you want to move it. Let's keep it where it is in slash home slash defcon slash workspace slash forensic slash, keep it there. We don't want to make another 50 megabyte copy of a file somewhere else. Let's do a symlink. Hit next. Okay, data integrity. Well, an MD5 hash can be used to verify the integrity of the image. Yeah, let's ignore it. We already did that. Analysis of the image file shows the following partitions. There's one partition. That's a mount point. That's C. FAT16. Okay. Fine. I'll just add it. Testing the partition linking. Okay. And I'm just hitting OK. All right. So now we've actually created a case. We've imported a disk. Now we can do analysis. Let's analyze the first thing that gets selected, which is a disk. Let's see what happens. Let's do an analyze. Well, there's no file analysis option. You can do a keyword search. Address. Okay, that's nice. Okay. Okay, I can do keyword search. But that's it. File analysis is not available. No file type. Image details. Okay. Nothing file analysis, no file type. That sucks. Alright, but what if I analyze the C drive? Okay, now it's interesting. Now file analysis is available. We can still do keyword search and file type. Let's go to file type. In this mode, Autopsy will examine an allocated and unallocated file and sort them into categories and verify the extension. Alright, this can be a time-intensive process. We can do that. Okay. Wait a minute. Let's do file analysis now. Let's see what happens. Alright, sort file by file type. Can you do this? No, we'll do it anyway. 59 files. 3 text files, 12 images? Okay. View sorted files. Aww. Okay. But let's go to sort by file type. Wait a minute. It sees, hold on, what did it find here? No, okay, 2 compressed files, 12 images, 3 text files, 29 unknown files. That's, okay, 1 extension mismatch, okay. Alright, let's go to file analysis and let's see what the hell is going on. In this mode, you can view file and content, directory content. Ooh. Hey, folks, I think we are looking at more than 2 or 7 files. You remember how many files that we? You remember the number of files that we saw initially when we opened up DMG the evidence.dmg file? Let me ask you this: what do you think the red means in Salute Kit and Autopsy? What do you think all this red means? Take a wild guess. What do you think the red? Mm-hmm. Not only the recovered file, deleted files. Let's look further. The blue means it exists. You remember trash as temporary items? We've seen that already. We should have seen that before. But whoa, we have a WebP here. What about this? We have a bunch of red files here. Did you remember seeing this file on evidence.dmg on the Mac? I don't remember seeing this picture on the USB stick. I mean, on the evidence.dmg. Yep, the red are the we didn't see these pictures for sure. No. Stacked. This wasn't the dry. The blue is the visible ones. And in fact, stack.txt is the paper smashing the stack for fun and profit by Leaf One. This is a quintessential paper on Stack Overflow. And the WebP, we took a look at. We already seen that one. And that's binary data of the picture. Yeah, so we have been lucky enough to recover a whole bunch of files. So all these files marked in red. Yeah, we are able to actually take a look at all the deleted files on the drive. I think that's it. I think we can call this a day. I think we can close the host and close the case. Yeah, we can close the case. So now I think, well, I'm going to hit Control C to exit. And I'm still in the forensics folder here. But sometimes you just want to have a nice quick way to just rip files and without even using a tool like Autopsy, Salute Kit, or Ncase. And I'm going to take a stroll down memory lane now. And I want to get to the talk that I gave to the HTCIA, the High Tech Crime, apparently it's High Technology Crime Investigation Association. I gave this presentation in 2009. Want to give a shout out to the HTCIA, htcia.org. I think they recently renamed themselves. The High Technology Crime Investigation Association was created, okay? Yeah, and we're the oldest and most prestigious association that's solely focused on high tech investigation. I used to be a member for 10 years. Um, you need to have sign off. You need to have like 2 members vouch for you. Want to give a shout out to Medford Police, Larry James, JJ McLean, HTCIA. Became a member in like 2005, and you know, it was such a great networking opportunity. Um, got to where I am today. Um, One of the best things I did early in my career was to actually get to know the organization, get to know people, and HDCIA gave me that opportunity, and certainly wouldn't be here without JJ and Medford Police and Larry. Yeah, heard that Larry is no longer in Medford Police. JJ retired a long time ago, but want to give a shout out to you guys. Haven't forgotten about you. Thank you. You know, I mentioned this like each and every semester. Yeah, but HDCIA gives a lot, do a lot of events. They used to have absolutely, the New England group used to have like the best holiday parties. It was around this time of the year. Fun time. But they do a lot of education as well for law enforcement agents. And I gave a presentation in 2009 on incident investigations and incident response using Backtrack, which is now Kali Linux. And surprisingly, is most of the content still is intact today. Uh, Using Kali Linux, there's a lot of forensics tools that are there, that are installed. Um, DCF-LDD is created by the Department of Defense Cyber Forensics Lab. Um, Also want to give a shout out to former head Jim Christie. Gave me a Department of Defense challenge coin. And what DD does, it resolves some of the shortcomings that I talked about of DD, such as status bar, hash values on the fly, verbose mode. This is now actually part of Kali Linux now. Okay. There's also DD underscore rescue to rescue a damaged disk. If it try to read a sector, it will actually not fail. It will go on to the next one. Now, this is one of my favorites. It's Foremost. That's the one I want to talk about. Foremost. It was also created by Department of Defense DC3. It's for file carving. All you need to do is, you feed in a disk image, um, and what it will do is read data structures, and it will just rip out files of certain type. Like if you want to rip out all the JPEGs, this is the command that you use. So you do foremost minus S, skip the first 100 blocks, minus T as a type JPEG, and then you feed in the image, the image of the disk. So here I am. So I have evidence.dmg. I do foremost minus S minus low s. Skip the first 100 blocks. Type I'm going to rip out all the JPEGs from evidence.dmg, hit enter, boom. Do an ls, creates an output folder, see the output, more audit.txt, and foremost ripped out 1, 2, 3, 4, 5 JPEG files. Just like that. Go to my workspace, got a forensics, got an output, got a JPEG, open the folder, and there it is. All 5 JPEG files that were in the disk image, including, and of course, Foremost will rip out the deleted files or the ones that were deleted by RM files on the disk. You can also use it to, you have to delete. This is one of the painful things. If you want to rip out PNGs, we can do that too. There it is. And you did not see these pictures in the original double click of the mount of the evidence. drive. And there it is. That is Foremost. Recovers files using the headers, footers, and data structures. Here it is. It supports JPEG, GIF, PNG, BMP, AVI. You can even rip our MPEG, EXE file, WAV, RIP, PDFs, Microsoft Word document, even zips. Source code. Time has changed. Pretty cool. Yeah. Vinito actually extract information from the annoying thumbs.db files. Yeah, but this is pretty much it I got for today, right? I think this is all. I'm pretty much done with this. I'm gonna log out. So yeah, I did an example of DD. We ran SleuthKit and Autopsy. And we even did file carving with Foremost. And you may be wondering, like, where do we go from here? Where we go from here is the next step is incident handling. So what incident handling is, something on a more greater scale, is logistic, communications, coordination, planning in order to resolve an incident. Now, an incident can be anything in a calm and effective manner so you don't have to bark up the wrong tree. You know what? I am going to stop here for a very good reason. A very good reason why I'm going to stop here for today is because I want to save incident handling for next week. Not next week, in 2 weeks, when the final quick stream of the semester, which is going to be on where do you go from here? What opportunities do you have? Including things like certifications. And this is a good place to start off in 2 weeks when we come back on Twitch. Uh, Career opportunities, where do you go from here, courses that you want to take. We're going to do that next in 2 weeks after Thanksgiving. So with that said, yeah, the final Twitch stream, where do you go from here? And that, my friends, we are done for the day. Yeah, so now you know how to recover files off of the recover file deleted using RM. Yeah, using RM. Yeah. Thanks, everyone. See you in 2 weeks and happy Thanksgiving. We are done for today.